Okay, so great. I think we can start now. So in the last session, we have discussed about two-phase locking protocol. So today we are going to discuss about timestamp based protocol. Okay. So let me share my screen. Okay. Yeah. So is my screen is visible?
Yes, sir.
Okay. Thank you. Yeah. So this is timestamp based protocol. So in two-phase locking, what we do? So whichever transaction got the lock first, like acquire the lock first, that transaction will get executed, right? So this is how we achieve serializability in the two-phase locking protocol. But in the case of timestamp-based protocol, whichever the transaction is entering first into the system, that transaction will get executed first. So how to decide that? So based on the timestamp. Okay. So now let's start. So what is the timestamp first? Okay, so whenever a transaction is entered into a system, so a DBMS system allotted with a particular timestamp. Okay, so it issued a timestamp to a particular transaction. Okay, so suppose this transaction TI, this transaction TJ. So if TI enters the first into a DBMS system, so this transaction it will allocate by some particular timestamp. Okay, and so this transaction will become the older one, and this TJ will become the younger one. Okay, such that like TI has a timestamp of TS TI, so we did not like this timestamp of TI, and a new transaction TJ is assigned with the timestamp of TJ. Okay, so such that timestamp of TI is less than timestamp of TJ, means this transaction TI enters first into the system. So this is the older one, and this is the younger one. Okay, yeah. So how we achieve the serializability in this timestamp based protocol? So this manage concurrent execution such that the timestamp determine the serializability order. So we'll see how this timestamp determine the order. Okay. So now, okay. So in order to assure that such behavior, the protocol maintains each data queue to timestamp value. So I will represent this write timestamp by WTS of Q, which is the largest timestamp, or it is the latest timestamp of any transaction that executed write operation successfully. And this is the read timestamp. So I will denote it as RT as of Q. So it is the largest timestamp of any transaction that executed read operation successfully. Okay. Now, how we decide that which transaction will get executed first? How should we ensure that the older transaction will get executed first? Okay, so if if TI enters the first into system and then TJ, so how we ensure that TI will execute first and then TJ? Okay, so this is some rules for timestamp ordering protocol. We'll discuss that. Same thing is given in the slide also. I have just simplified it. Okay. Okay, so any doubt till now? Any question? Yes, anyone? I'm audible, right?
Yes, sir.
Sir, actually, I have a doubt in the previous slide.
Previous slide, okay. Yes.
Sir, here W timestamp is the largest timestamp. The statement tells us the final rate or the first rate in the transaction.
Yeah, which of the transaction has executed the final write operation, so that timestamp is allotted to this WTSQ.
Okay, sir.
Yeah, we'll see with the example also. Okay, so these are the rules that we can check whether the timestamp is following this protocol or not, like our schedule. Okay, so say suppose a transaction TI. Okay, so let us say we have two transactions, say TI and say TJ. Okay, and a timestamp of TI say 5, timestamp of TJ say 10. Okay, and so TJ read the perform the write operation first on time. Okay, on data item say Q, and here TI reads the data item Q. Okay, but this transaction enters the system first. Okay, so now let's see. Suppose the transaction TI issues a read Q. Okay, so this Tj already performed the write operation, but now this Ti issued a read queue. Okay, so now let us check if a timestamp of Ti is less than the write timestamp of Q. So here the write timestamp of Q is 10, right? That is the latest read of this particular data item Q, right? So 10. Now this and the timestamp of this particular Ti is 5. So 5 is less than 10, right? So this condition gets satisfied. So we need to roll back this transaction Ti, right? Because based on this timestamp ordering protocol, the Ti should get executed first. After that Tj, right? But here it is reading the Tj is reading the first, not reading, writing the data item, right? And after that it is reading. So we cannot allow this, right? So that's why this Ti gets rolled back. Okay. Same case with the write operation also. Suppose here it is write of Q. Now there is two conflict for write. That is with read of Q and write of Q, right? So we need to check for the both the condition. If any of this condition is true, then we need to roll back this Ti. Okay. The same case for write operation also. Like timestamp of Ti is less than the write timestamp of Q. So we need to roll back this particular transaction. Okay. So we'll apply these rules. Okay. So please follow this rule, or you can remember this, or once you practice this for 2-3 examples, you can easily follow these rules. Okay. Now here, if a TI issues a read queue operation, and if a timestamp of that particular transaction less than the right timestamp, then we need to roll back it. Otherwise, we can perform that read operation and we can set the right timestamp as maximum of right timestamp of queue, or whichever is greater than this two. Okay. Now suppose that transaction TI issues write of queue, then we need to check for this condition. Okay, so if these two conditions are true, then we need to roll back that particular transaction, or otherwise the system will execute the write operation and we can set the new timestamp as TI. Okay, so now in the slide there is one example like this. Okay, so here you can see the professor has explained that the transaction T2 got aborted, right? So how to check this? By following these protocols. Okay, so let's say we have a timestamp of T1, say 1, 2, 3, 4, and 5. Okay, now let's see. So initially what we do, initially the write timestamp and the read timestamp of all the data item will be 0, right? So here we have 3 data items, say X, Y, and Z, and here it is write timestamp, sorry, read, this is write timestamp. Okay, so now initially these all are 0. Now you can see that read of X. Okay, so if we want to perform the read of X, then what are the conditions for that? Yeah, for read of Q, we can see if a timestamp of transaction Ti is less than the right timestamp of transaction Q, then we need to roll back. Otherwise, we'll perform the operation. Now here initially all the write timestamp and read timestamp are set to 0. So here this 5 is greater than 0, means we can perform this read operation and we can set the new timestamp, that is maximum of our timestamp Q or timestamp of Ti. So here, so write timestamp of this particular data item will be set to maximum of this. So it is 5. Right? Now similarly for this data item also, read of Y. Here also it is greater than 0, so we can execute this operation. And now we can set this data item, that is write timestamp for Y, is maximum of 2 or 0. So that is 2, right? Now here also, now we need to compare this data item with the right timestamp. Okay, here you can see the first condition. If a timestamp is for a particular operation read, we have to compare the timestamp of particular transaction with the right timestamp. Okay, so if it is greater than right timestamp, then we perform the read operation. Now let's see here, the timestamp for this particular transaction is 1 and the right timestamp for this is 0. Okay, so we can perform this read operation, but we need to set this right timestamp such that maximum of previous timestamp, that is 2, that is timestamp of Ti, that is 1. So here maximum is 2. So we already set it to 2, right?
Excuse me, sir.
Yes.
Sir, but if we talk about like read and read never conflict, so do we really need to check this?
No, we don't need to check this. I'm just showing an example. Like follow
Okay,
it.
okay.
Read and it is not a conflict, right?
Yeah.
Yeah, it's the same data item or the also. So we don't need to check that. So I'm showing this because like based on this concept, there are a few example in the practice assignments. So we'll follow the same steps. That's why. Okay. Yeah, but here you can see there is a conflict between read of y and write of y, right? Now for this, we need to check this condition, that is write of y. So for write of y, we need to follow these two particular conditions. Now let's see. Okay, so what is the condition for the this write operation? The timestamp of T3, that is 3, is first we need to check with the write timestamp, right? So it is greater than, okay, y, yes, so it is greater than 2, right? So we can perform this write operation. Similarly, it is greater than 0 also, because we need to check for both the condition here. Okay, and same for write of z also, right?
Sir, one question.
Yes.
Sir, actually, in this case, TS of TI is the current transaction which you are referring to. Am I right, sir?
TS of TI?
TS of TI. TI is now for
TS of TI.
example.
That is the current transaction that executing this particular operation. Yeah.
Okay, sir. When we are checking for read Y in T1,
And TI become T3. Sorry, here.
TI is going to be.
So if you're reading this Y in transaction T1, so TI will become T1, right?
Okay, sir. Then the stamp for write and read will be the previous transactions read or write, sir.
Yeah, latest one before that, what you are executing.
Okay, sir. Okay.
So yeah, so for write of,
Sir, how you wrote this 3 greater than 2?
okay. So we are checking for this write of Y, okay?
Yeah.
Yeah, so we are checking for this write of Y. So what are the conditions for write? Like if a read timestamp of a particular this data item is greater than this timestamp, then we need to roll back, right? So here the timestamp of T3 is 3, okay? And what is the read timestamp for this particular data item? That is 2, right?
Yeah, 2.
Yeah, so that condition is not satisfied. So we need to execute that particular operation, that is write operation, and we need to set the WTS of this particular data item to TS of this. So here we are for data item Y, like here you can see. Yeah, so otherwise the system will execute the write operation and set the timestamp Q to TS, right?
So this is like this is not satisfying. So this should be rollback at this particular point of time.
Why it is not satisfying? It's satisfying, right?
TSTI, like current transaction is 3, right? And read timestamp is 2.
Okay, so let me write the conditions first. Okay, for read, okay, for write, okay, so for write, the condition is, say, if RTS of this Q is greater than timestamp of TI, then we need to roll back. Also, if WTS of Q is greater than the timestamp of TI, then also we need to roll back, right? We need to roll back. Otherwise, we can execute this. Now here, the timestamp of T3, that is 3, and RTS and WTS of this Y is 2 and 0, right? So 3 is, so this condition is not getting satisfied, right? With both the condition. So otherwise, we need to execute this operation and we need to set to new timestamp, that is WTS of Y to 3. Okay. So here you can see these two conditions. Both the condition is not getting satisfied because the timestamp of that T3 is 3 and read timestamp is 2 and write timestamp is 0, right?
Yes, sir.
So both the condition is not satisfying. So otherwise the system will execute the write operation and we need to set this timestamp to TS of Q.
Okay.
So we are setting this timestamp to 3. Now let us check for data item Z. Okay. So timestamp is 3. So both the initially read and write are 0. So anyway, this condition is not true. So we need to execute this operation. And we can set it to 3. Right. Now read of Z. Now like we need to perform the read operation on this particular Z item, right? So now, yeah. So now we will see why we are rollbacking this particular transaction. Okay. So what are the conditions for read operation? When PI issues the read operation, which is write of Q is greater than of TS of TN, then we need to roll back. Otherwise, we can perform the operation. Right. So the read of Z, that is timestamp of T2 is 2. But the rank, okay, so right timestamp of Z will be 3 here. So this condition is getting satisfied, right? It is Z here. Right timestamp of Z is 3 that we have set during this operation. And now the timestamp of Ti, that is T2, is 2, right? So this condition becomes true. So we need to roll back this particular transaction. Okay, so in timestamp based protocol, we are not allowing this particular transaction to happen. So we are aborting this transaction, right?
Yes, sir.
Yeah. So in this way, we need to check for all the cases. Okay. So here, if you observe, if you go follow these two operations, then this transaction also we need to roll back. Okay. So you can try it out. Yes. Any doubt in this?
Hello, sir.
Hello. Yes. Yes.
How are
Anyone?
we? Sir, hello. Am I audible, sir?
Little low. Can you speak louder?
Yes, sir. Now is it okay?
Okay.
Sir, how are we, assigning this time to each transaction? I mean, based on what are we assigning this timestamp?
This 1, 2, 3, 4, 5.
Yes, sir. Yes, sir.
So whenever the transaction enters the system, this DBMS system will automatically will allot to this particular timestamp to any transaction. So it depends on a database system. If a transaction T1 is entered first, so it will allocate 1. So see, so there are two ways to implement this timestamp. So first one is like a system lock. And second one is the logical counter. Okay. So system clock means suppose this transaction T1 enters system at particular date and particular time. So that date, the combination of date and time will be allocated to this transaction. But it will be very difficult to track that particular date and time combination, right? So some database system use logical counters also. So it will allocate like any number like 1, 2, 3, 4, 5. So it's based on the DBMS system.
Okay, sir. Once the once let's say this transaction T1 enters the system first, then it will always get the first preference.
Yeah. In this protocol, timestamp based protocol. Yeah.
Yes, sir. In
T1 should get executed first. Yeah.
T1 should execute first. Even let's say after that T2 executes and all that. And if there is a conflict between T1 and T3, then T1 will be executed first.
Yeah, so we need to roll back this operation T3, right?
In case of conflict.
Yeah, so suppose we have T1 and T3.
Both are trying to read data.
So yeah, so first it write the particular data item, and now this transaction, which is the older one, so this is the older one, is writing this value or reading this A and writing this A, right? But it is not allowed, right? Because this is writing this particular value and then this transaction is reading. Okay. So its condition is not satisfying here if you follow this rules.
Yes,
okay?
Yes.
So we need to roll back T3.
Okay, okay, okay.
Oh, sorry,
So
T1.
there is no chance of conflict only in timestamp protocol.
Yeah, in timestamp protocol, we give the
I mean,
we
whenever
obtain
there is
the conflict serializability. We achieve conflict serializability here in the case of timestamp based protocol.
what I was trying to say was that I mean, in case of timestamp protocol, we don't face a deadlock like situation ever, because before that
Yeah.
happens, we roll back, right?
Yes, deadlock will not happen, but starvation may happen, right?
Yes, starvation may happen, but deadlock will not happen.
Deadlock will not happen.
Yes.
Yes, it is deadlock free. It's deadlock free, but starvation may happen, right? Okay. Now, if you understood this particular rules of timestamp ordering protocol, then there is the modified version of this protocol. So that is Thomas Wright rule. Okay. So all the conditions are same as of a timestamp based protocol. Only the difference is in the second point. So in timestamp, what we do, like timestamp based protocol, if this transaction of if the timestamp of Ti is less than the right timestamp of Q, we simply roll back, right? In the case of timestamp based protocol, but here the Ti is attempting to write an absolute value of Q. Okay, so that's what we discussed. So this write operation will be ignored. So this will not execute the write operation. We can simply ignore that particular write operation, and we can go back, go to the next operation. Okay, the same rules are there. Only difference is this second of point. Whenever the Ti is issuing the write of Q, here you can see write of Q. Here second point is if Ts of Ti is less than W timestamp of Q, then we need to roll back Ti. But here what we are saying, if this Ts of T is less than a W timestamp of Q, we can simply ignore this particular operation. That is right of Q. Okay, and we can proceed to the next operation. And then otherwise we can set it to W timestamp of Q to Ts of Ti. Right. So this is the modified timestamp based protocol. Okay, this is Thomas Wright rule applicable whenever we are issuing the write operation. Okay, so please make sure this note it down. Okay, so I have taken this reference, like our reference book only. It is DBMS by Korth and Sudarshan. Okay, our reference book. Okay, it is there in the reference book. Okay, you can refer to that also.
Sir, in timestamp based protocol, when we issue TA, when TA issues a write of queue, should both the conditions be satisfied, or if any one is satisfied, we can roll back?
No, both the conditions should satisfy, because there is conflict with read operation also and write operation also, right?
Yes, sir. Yes, sir. Okay.
Both the conditions satisfied. Both should satisfy. Sorry, if any one of these conditions satisfied, then we need to roll back. In the case of this timestamp based protocol, but in the case of Thomas Wright rule, we can ignore the second condition.
Ignore means ignore to roll back. No, sir. We can ignore the rollback of this transaction.
Yeah. So suppose if you are applying this timestamp here, right of Q. So if it is not satisfying that condition, second condition, so we can simply skip that this part. Yeah, we will not roll back in the case of Thomas Wright rule.
We will write the data and get along with it. Right?
No, we will not write the data also. We can simply skip that.
Okay, we
can
totally
ignore that transaction. Yeah.
Ignore the whole write W. Okay, so we are. So why? So sir, by obsolete I know that something which is not in use anymore. So what it is trying to do, sir? Can you please, if you please explain a bit, like why it is becoming obsolete and why are we ignoring it?
Yeah. Okay, so in this. Okay, so there are two data items, T1 and T2. It is performing read of A Then this right of A. Okay, so this read of A, right of A, again right of A. Okay, let's try. This 5, this 10. 10, 15, 10. Okay, so if we set it to 0, okay, so I think there is one example that will follow the Thermostat rule. Yeah, in this I will explain that. Okay, so
Okay,
this
sir.
is the good example. I am not able to formulate that example because it reading the data, value from which is performed by the younger transaction, right? What is this condition mean here? TS of Ti is greater than WTS of Q. So what this condition mean?
Means
Means, yeah. So this data item Q is already written by younger transaction, right?
TS TI. Then we should know. So
Yes.
yes, let's say there is a transaction with timestamp 3 that
Mhm.
has written the data. So the WTS of Q will be 3 then.
Okay, so okay, on this operation, right? Suppose T1 is T2 is there, and we are writing this Q. It is having 3, but it is having 1. Okay, so this Ti enters first into system,
Yes, sir.
and this is right of Q. Okay, so before that there are many operations also. Okay, it
Yes,
is not
sir.
starting from right of Q.
Yes, sir. Yes.
Yeah. Now, if
So
you apply this condition, right of Q, the timestamp of Ti is 1, but the latest right timestamp of this data item is 3, right?
3. Yes,
So
sir.
this condition is satisfying. So in the case of TBP, like we are just simply roll back in this transaction. But here we are just keeping this transaction. We are ignoring this transaction and we are proceeding further.
Yes. So,
Because both the data items writing the same value, right?
yes, sir. But let's say the transaction T2 is setting the value to, let's say, 50.
Okay.
Value as 50. And
Hmm.
now transaction T1 is supposed to set the value at 30.
Okay. Hmm.
Okay, now I understand, because as we are supposed, as transaction T1 is supposed to write the value, then transaction T2 should write the value. So anyway, the T2 is writing the value. That means we will be end up with T2's value only. Let's say T1 is writing the value as 30, and T2 should write the value as 50.
As 50. Okay.
50, yes, sir.
Hmm.
No,
Then,
T2, sir. T2 should write the, yes, sir. So
hmm.
at the end of the day, we should check that our system is showing the value as 50 or not, because that should be the final value.
No, 50 should not be the final value, right?
Let's say these two transactions is only happening.
Okay.
Only these two transactions is only these two transactions are happening, and we will have to check at the end of the day. We have to check the balance and we see if the
Yeah.
value is 50 or not.
At the end of a transaction, we need to check whether the same value is there or not for this particular data item. If TI starts first. Yeah. Yes, Abhishek, continue.
I mean, so the thing that I understood, I am trying to say you that, so that you can say whether I understood it right or not.
Mhm.
So what I understood is, if T1 is doing the right first, that is T1 is setting the value of A to 30, and then T2 is supposed to first T1 should execute the right operation, then T2 is supposed to execute the right operation according to our timestamp theory. Because yes, this should happen.
Yeah.
50. This one is 50. Yes, this should happen. This should happen according to our timestamp
Timestamp.
protocol. Yes, sir. So anyway, if we are writing, there is some problem, and we end up the write operation of T2 ends up being executed first, and then we start writing the T1 of writing T1 operation, T1 transaction. So we can just ignore that because we are anyway supposed to end up with the write of transaction 2.
Right of transaction to
I mean, we are supposed to in this, if we follow this timestamp theory, we should end up with the value of Q as 50.
Q as 50. Okay, yes, yeah.
So if I am executing W2 first and W1 last, then we are and then we according to Thomas Wright rule, if we ignore the W1 of 30, then we are ending up with W2 of 50 only. So we can, that's why we are ignoring it, right?
No, we need to check the
Okay,
condition.
okay, sir. Maybe afterwards we can.
Yeah. Because this should not happen, right? If a transaction T1 is entering the first, then it should get executed first, right? So it is completely, so here, if you see 30, okay, yeah. Okay, let's see this example. Okay, this example follows timestamp rule. We'll discuss here, okay?
Yes, sir. Yes.
Yeah. Because we are just simply assuming the two transactions here, so may not be the correct case. Okay, so anyone has any doubt in this Thomas Wright rule? Only slight modification is there in the timestamp-based protocol. We are just ignoring the second condition, okay? And we're executing, otherwise we're executing this write operation, okay? So please note it down. Yeah, so let's see. This is the practice assignment question. Okay, anyone tried this question? T1 is there. T2 is there. T3. So W of A, R of A, then R of A, and W of A, W of A, 2 of B, W of C. Okay. So this is our schedule. Okay. Yes. Now, if a timestamp for this transaction T1, T2, T3 are, this is 20, this is 5, and this is 10. Right. So T2 is the older transaction here. This is question number 8. Okay, yeah. So what are the conditions for timestamp based protocol? Like if you need to check it for. Okay, so we need to check whether this following this timestamp based protocol also and with Thomas rule or not. Okay. So first we'll check for TOP, take timestamp ordering protocol. So the first is like initially we set all the data items to 0, right? So we have ABC here. ABC right of S, read of PS 0, 0, 0. Okay, so first it's write of A. So it is anyway. So what is the condition for write operation here? Yes. So if the write timestamp or read timestamp of this particular data item Q is greater than this timestamp of T, then we can roll back. But here in this case, 5 is greater than 0, right? So we can perform this operation and we can set it to like WTS of A to 5, right? Now simply for read of A, now here also, yeah. So it is reading the data item A. So what are the conditions for read operation? If WTS of A is greater than TS of TA, then we need to roll back. Otherwise, we can perform the operation. But here, WTS of is 5. and it is timestamp as 20. So this condition is not satisfied. So we no need to roll back. Simply we can perform this operation and we can set it to RTS of A to maximum of RTS of A into timestamp of TA or timestamp of TA. So 20 is there. So we need to set it to 20, right? Now let us check for this read operation. T3. Yeah. So read of A here. What are the condition? Same condition, right? For read operation, it is not conflicting anyway, so it will satisfy the condition. Here you can see for transaction T3, it is 0 and 0 is less than of 10. So we can simply execute this operation and we can set it to RTS of this particular. Oh, okay. We are working on RA only, sorry.
Sir, it is A. We are working on A.
Yeah, we are working on A only, read of A. So read of A is in this case, what is the condition, right? Is 5 and 5 is not greater than 10. The timestamp of 3 is 10. So we no need to roll back. We can simply execute this operation and we can set it to maximum of RTS is 20, 10, right? So 20 is maximum here. So already we have set this to 20. Okay. Now here.
Sir, actually I have a doubt over here.
Yes.
Sir, in this case, for R3 of A, we took WTS from T2, sir.
WTS?
WTS of A is from T2, right?
WTS of A is 5, right? And 5 is not greater than this timestamp of this 10. So we cannot roll back this transaction, right?
Okay, sir. Okay. Got it. Thank you, sir.
Just 1 minute. If we have this. Okay, so can you see the condition also? Like I have snipped that. Can you see the two tab, or just you are seeing only one tab here?
One tab, sir. Only one tab.
Okay. So let me write the condition first. Otherwise, it's confusing. Okay. For read operation, WTS of any data item CQ is greater than the timestamp of TN, then we need to roll back, right? Otherwise, we can execute this operation and set RTS of this particular data item to maximum of RTS of Q, comma timestamp of transaction T. Okay. This is for read. And for write, if RTS of Q or WTS of Q is greater than the timestamp of TI, then we need to roll back. Otherwise, we can execute and we have to set WTS of Q to timestamp of TI. Okay. So this is the condition. Now let us check for this. Okay, so we have checked the read of A. Now write of A. Now here we are performing the write operation. We need to check this condition. Now the timestamp for the A data item, right, is 5 and 20. Now the timestamp of T, that is T1, is 20 here. So if we see the condition, for the first we'll check for the RTS. So RTS is 20 and this is also 20. Because 20 is It is not greater than equal to, it is strictly greater than, okay? It is not equal to. So this condition is not satisfying, right? Now let us check for the right of t, that is 5. So 5 is also not greater than this 20. So otherwise we need to perform this operation and set WTS of Q. So here A to TS of TJ. So WTS of A to TS. So we need to set it to 20. Okay. This is also 20. So yes, anyone, any confusion in till this? Okay, so now let us check for this right operation. Now here RTS of Q, right? So RTS of A is 20 is greater than the timestamp of 10, right? So here we need to roll back this transaction because this condition is getting satisfied here, right? So we need to roll back this transaction. So this timestamp audit protocol does not allow this transaction. So our first option becomes 2, right? Is any confusion regarding this?
Sir, when we are rollbacking, so do we roll back every thing that we have done before this particular step?
Yeah, we are basically rollbacking transaction T3 only.
Okay, only T3,
Only
not
T3.
the T1 and T2. They will get on with it.
Yeah.
Okay.
Based on the rules, it will get executed.
Okay, sir.
So here this condition is not getting satisfied, so we are not allowing this transaction. Okay. Now what Thomas Wright rule says? Thomas Wright rule says if this condition, like second condition of the TWP, like timestamp of any data item Q is greater than TS of TI, we simply ignore this. Okay. Now, okay, so we have checked this. Now check for this right operation only because Thomas Wright will work on right operation. Now let us check for this W of A, right of A. Okay. So I think so we have updated this. Okay, I am erasing this now. So if we follow the timestamp based protocol till here, we are getting this latest WTS of 5 and RTS of 20. Now just check for this condition. It is right of A. It is right of A. The condition, yeah. The timestamp has 20 and 20 is greater. Yeah, so 5 is not greater than, so this condition is not satisfying, and 20 is also not greater than 20. Okay, so this is not, condition is not also not satisfying. So we don't need to roll back. We can simply perform this operation and set WTS of A to TS of TJ. So we are setting this to 20. Now also this operation right of A. Yeah. So here same condition is applied, right? 20 what is okay 10. So here WTS of A is 20, right? But the transaction is 10. So it is this condition is getting true here, but we are ignoring this condition in the Thomas Wright rule. Okay, but here the read timestamp of A, which is also 20, is greater than this 10. But this condition is getting true, right? So that's why we are getting we are rollbacking transaction 3. In the case of ordering protocol, both the conditions are getting violated. So both the conditions are getting true. So that's why we are rollbacking. But in the case of Thomas Wright rule, we are ignoring this particular thing, but this condition is becoming true. So that's why we need to roll back, right? So it will not allow with Thomas Wright rule also. Okay, no, sorry. Yeah. So A and C is the correct option. Any doubt, any confusion? I know it is little confusing, but once you solve this problem by your own, you will understand it in a better way. In the case of ordering protocol, both the conditions are getting satisfied. That's why rollbacking. But if we apply Thomas Wright rule, we are ignoring this particular condition, but still the first condition is getting satisfied. That's why we need to roll back. If in this case, so suppose this transaction, this RTS of it is 5 only. Okay, so this condition is not true. But if this condition is become true, we can ignore this part and we can simply move on to the next operation.
Sir, but if the same case happens in timestamp protocol, sir.
Yeah, same case happen in timestamp protocol. This condition will become true, right? So we need to roll back.
But the first one does not give the true value.
Either one of the condition. If this condition is true, then we need to roll back. If this condition is not true, but this condition is true, still we need to roll back. If any of this condition is true, A or B, we need to roll back the transaction period.
Okay, then there is no need of checking for both the conditions.
No,
If
no,
first
no.
one is
If first one is
true,
satisfying
then
this, then simply we need to roll back.
okay, sir.
Otherwise, if both the conditions are false, we can execute, right?
Yes.
Yeah, so this will be the good example. Let us say this is TI, T1, T2, T3. This is WA, read of A, W1 of A, W3 of A, W of B, W of C. So what is the difference between first and second schedule? So here,
There's no read in T1, sir.
yeah. So, okay, timestamp is 25, 10. Right. Okay. Okay, so we have 3 data items: A, B, C. Initially, it's all set to 0, right? Now simply we are checking for this condition. Okay, so anyway, it's 5 will be greater than both the condition, it is 0. So we can simply perform this operation and we can set the WTS of this transaction TA to TS. That is TS. It is 5 here. Now same for read. So read of A, what is the condition for read operation? Like WTS of A greater than TS of TI, then we need to roll back. But here is 5. Okay, so this condition is not true, right? So we don't need to roll back. We can perform this operation and we have to set RTS of A to maximum of timestamp of array is 10 and right timestamp it is 0, right? So maximum of 0 or 10 is 10. So we are setting it to 10. Yeah, so here it is right of A. So what are the conditions for right? So first we are applying timestamp ordering protocol. Okay. So for write operation, if RTS of A or WTS of A is greater than timestamp of TI, then we need to roll back, right? Then roll back. Otherwise, we can perform the operation. Now here you can see timestamp of TI is 20, and here RTS of WTS of both the data items 5 and 10. So both this condition is not getting true. So we can perform this operation and we can set it to set WTS of A to TS of TI. So WTS of A is 5. So we need to set it to 20. Right. Okay, so then write of A. Here also same condition is applied. 20 is greater than 20. Okay, then we have write the schedule correctly, right? 3, 4, 5, 6. Yeah, yeah, okay. Let us see the condition. Right of A. So conditions are 20 greater than or less than. Okay, this condition is false. So this is, oh, wait. Yeah, so right timestamp of A is 20 and the timestamp of this 3 is 10. So this condition is getting true, right? Here, WTS. So then here we need to roll back transaction 3. But now we are applying the Thomas-Wright rule here. Because this condition is not getting satisfied, this first one, that is 10 is not greater than 10, right? So only this condition is getting satisfied. So that's why we're getting rolled back. But in the case of Thomas-Wright rule, we simply ignore this operation, right? We can simply ignore this particular data item. And then we can move on to the next data item. So why we are ignoring this now? Yes, Abhishek, coming back to your point. In the case of timestamp ordering protocol, we are simply rollbacking because this condition is not satisfying. But in the case of Thomas-Wright rule, we are ignoring this condition. So if we ignore this condition, what will happen?
We move to T2, sir. T2 stand.
Yeah, we'll move to T2. But if anyway, like if there is no any operation here, okay. It is reading, writing the value from this T1, right?
Yes, sir.
So even if we ignore this operation, it will have the same value of A. Okay. Okay, so till now, any doubt here? Why we are ignoring this condition in the case of Thomas-Wright rule? Right? So we are rollbacking in the case of timestamp ordering protocols. It is not allowing the transaction. But in the case of Thomas-Wright rule, we simply ignore this condition, right? So then we can check for the read of B. And what is read of B here? B00 only. Okay, so anyway, the timestamp is 5 is greater than, we can simply execute this also and this also because working on different data items. So this schedule, like if we follow the timestamp ordering with Thomas-Wright rule, it will allow the transaction, right? Just any doubt, any confusion? I know it is little confusing, but when you solve this problem, no, you understand. Just remember this condition, okay? This thing rules, and this Thomas-Wright rule also, second condition. Just any doubt in this timestamp based protocol?
Actually, one question is the T1, T2, T3, we started from the T2, right? Is minimum time need to be considered for that?
Can you speak louder? Yes.
Yeah, actually
Huh.
WA, first I select the T2 one, right? Started from T2. So this is based on the time stamp?
This
Yeah.
transaction T2.
Yeah, T1, T2,
Yeah.
T3, right? So I
Mhm.
started from T2, right?
Yes, we are started from T2.
But what is the reason? I mean, is the minimum time stamp?
Yeah, because T2 enters the first, right? In the system is minimum timestamp. So it should write the data item first. Now we are keep the schedule in this way only. Like not in this way, like for this example.
Yeah, I mean, what is the reason that I put it to be? Because T1, T2, T3, right? So T1 is transition 1. So I'm identifying the transition 1. So I thought, okay, it will execute first and then T2 and then T3. Due to the timestamp, I have to choose these things, right? This way, right? W1, then R, read A,
No, this operation is performed by the transaction T2, right? So DBMS system will allow this particular this transaction serializability in this based on this timestamp of a transaction. Is this your doubt? Like, I'm not able to get you.
Actually, W2, R3, W1, W3, R2, we just place in the transaction 1, transaction 2, right? I mean, nothing mentioned over here. So how we are doing that? That's what my question.
No, we have considered this one of the schedule.
Yeah,
For
yeah.
example,
And we are write down. I mean, we are what was this? I mean, we are putting into the table T2. I mean, based on the timestamp, right?
Yes, Asim.
Yeah. So that's why.
Okay. Yeah. Okay. Yeah. So, any doubt in this week? Week 10, right? Any practice question or activity question?
Sir, practice assignment 10, question 3.
Practice assignment 10, question 3. Okay. Let me check.
Okay. Okay, sir. Sir, can I take this? Hello.
Let me check the question. Question. Yes, Subin. Yeah. You can take.
Okay, first we'll solve some question, then we'll take your doubt.
This
So
question is added in that question, right?
yes, at the end of the
Okay.
okay, so my screen is visible, right?
Yes, sir.
Okay. So if a schedule S consists of 4 transactions, then the number of serial schedules. Please write your answer in the chat box. I will wait 2-3 minutes, then we'll discuss. Okay, so yeah, maximum people got right answer. Anyone want to have 24 is the right answer? Anyone want to tell? Hello? Am I audible, right?
Yes, sir.
Okay. So how to proceed these types of problem? Can you tell?
Sir, we have 4 transactions.
Yes.
So so that we can have 4 schedules over here.
No,
And
4 transactions.
yeah, sir, for 4
One,
transactions.
one schedule and 4 transactions. T1, T2, T3, and T4. So you have to tell then the number of serial schedule. How many serial schedule can be possible? Okay. So if there are 2 transactions, then how many serial schedule is possible?
So 2.
Yeah, 2. How? T1,
T1
T2.
after T2 or T2 after T1?
Okay. If there are 3 schedule, T1, T2, T3, then how many serial schedule is possible?
Sir, 6.
How 6?
Sir, 3 factorial.
Yeah. So 2 factorial. If there are 2 transactions, then 2 factorial. If there are 3 transactions, then 3 factorial. So consist of 4 transactions, then 4 factorial equal to 24. So if anyone have doubt in this question, you can ask. Okay. So we'll move to the next question. So Tom is working as a system engineer in a reputed firm. He has 3 transactions to be analyzed as follows: T1, T2, and T3. His analysis involves checking each possible concurrent schedule that can be made using the transaction. How many schedule does Tom have to check? Basically, you have to find number of possible concurrent schedule. So I will wait 1-2 minutes, then we will discuss. Write your answer in the chat box.
I think Subhendu, yes, you can explain this.
Yes. Okay. So T1 have how many have transaction? Means T1 has 3, right? Hello.
Hello, sir.
Yeah. So,
T1 has 2 transactions.
2 transactions.
yeah. Sorry. 2. Sorry. T1 has 2, T2 2, and T3
1.
okay 1. Okay, so the number of concurrent schedule is 2 plus 1 factorial by 2 factorial 1 factorial. Everyone got this? How come this formula? So there will be 120 by 5. So yes, no, yeah, so 4. So 30. Everyone got this?
No, sir.
Okay, suppose, okay, let me.
Is it grouping things, sir?
Yes, suppose you can remember the formula, right? Suppose and transaction N1 has, suppose A operation, N2 has B operation, number of operation, N3 has number of operation C. Then you can directly write the formula is A plus B plus C plus dot N is factorial by A factorial, B factorial, C factorial dot. You can directly.
Bindu, may I?
Yeah.
Yeah, you can see there are the how many numbers of the instruction are there. There are 5 means instruction. Yeah. So how many possibility of arrangement if you do the permutation?
5 factorial.
5 factorial. And see the individual transaction. That is the W1 and the W1C in the first transaction. In the particular transaction, whenever the concurrent or any means or the serial schedule happen, you cannot interchange this particular, cannot swap this instruction, right? So can you write W1A and the W1C? Am I audible?
Yes.
Yeah. In the T1 you can write T1. No. In the time in just below T1, write W1A and W1C.
Okay. This.
No. Just here, wherever you. Yeah. Just write T1 and sun. Yeah, ladder. Label. Just T1. Just write T1.
Okay, T1.
And the below that,
Okay.
T1. Yeah. W1A. Yeah. You cannot write this thing as the W1C and after that's the W1A, because set of transaction or operation, this set of operation are fixed, right? WC always come after the WA. Is it clear to everyone?
Yes,
so
sir.
that's why we are writing the divided by 2 factorial, right?
Yes.
Yeah. You everyone got this one.
Sir, if we had any conflict between the transactions,
which one? Then we have to individually check in that.
Okay.
So you have to make the pair, that particular pair. That's where math will. I need everyone know about the permutation combination. So you have to do that. Hello.
Yeah.
Yeah. Subandhu, you can.
Yeah. Thanks, Pradeep. So someone has doubt on question number 3. So let's discuss question number 3. So yeah. So who asking that question number 3?
Or I asked.
Okay. So can you tell what are the condition of view serial eligible?
Sir, the initial read must be performed by the same
Initial
transaction.
initial read. Initial read should be same,
Yes, sir.
right? Okay. And the second is
The read and write pair should be maintained.
okay. The right pair maintained. And the third
final-
condition is
Final write should be the same.
okay. Final right.
Bindu,
Yeah.
in the second point is the right read. Okay.
Oh,
Not
yeah.
read, right?
Okay. Final right should be the same, right?
Yes, sir.
Okay. Okay, then. So focus on second point. So any right read means right read pair in this schedule.
No, sir.
Okay, so this is no. Okay, then initial read. So initial read of S
Transaction 1.
transaction 1, and the Q.
Q is a blind write. There is no initial.
Okay, and the P.
Transaction 3.
Transaction 3. Okay. Okay, then final write. What is the final write means which transaction?
Transaction 3 is writing Q.
Okay. Final write transaction 3. So total number of operation is
5.
okay. Then so this must be the last at the last transaction T3. Final write should be the same.
Yes, sir.
Okay, then total number of operation we can number is 4.
Yes, sir.
So possible concurrent schedule using 4 factorial by transaction T1 has 2 factorial, and the
Factorial 1 factorial.
1 factorial. So what is the is 12, right?
Yes, sir.
And the question is the what is the number of schedule which are view equivalent to the given schedule? So you have to subtract 1.
1.
Okay, so 11, right?
Yes, sir.
You got this?
Yes, sir.
Okay, thanks. Okay,
So
so
we should be subtracted by 1. Can you repeat?
yeah.
Given schedule itself view equivalent, right?
Sure.
What? Yes, sir.
Yes, given schedule also it's equivalent to the view equivalent, right? So this is
Yes,
also
sir, yes, sir. Okay.
this is this is also
We have a
Bindu,
blind.
Yeah.
may I? Okay.
yeah.
You can see what is the numbers of schedule which are view equivalent, right? Up to this is in question it is given, then you can say there is the 12. So after that you can see to the given schedule. So it is explicitly mentioned that equivalent. I hope you get.
Yes,
Hello?
sir. Yes, sir. I got it.
Sir, we took the right condition into account. Shouldn't we have to account for the read condition as well?
See,
Where?
yeah. Hello.
Yes,
Am
sir.
I- So see transaction if you arrangement any possible, so initial would be only transaction means read is sorry means initiality of s only means read of s only t1, right?
Yes, sir.
Yeah, hello.
Yes, sir.
And so it can means if you arrange anyway, the initial would be of s is t1 if you arrange anyway, because only s data item read t1.
Acha, okay, got it, sir. So this would be different if T2 or T3 were reading S.
Yeah.
Okay, sir. Got it.
Okay, so we'll move to the next question. Okay, so given schedule S is given as R2A, W1B, R3B, R1A, W2A, R3A. So you have to say, is this conflict serializable or not? So I will wait 2-3 minutes. Please means answer in the chat box. Okay. Hello, am I audible?
Yes, sir.
So is this conflict serializable?
Yes, sir, it is conflict.
Okay, so let's start the transaction. T1, then T2, and then T3. Okay, then R2A. So read A, then write B, write 1B, then read 3B, R1A, then WA, and R3A. So let's draw precedence graph. T1, T2, T3. So is this any conflict? Right. Yeah.
The RB after RB, RA, you have right, that is little confusing. RB after RB, you writes in the, you
Okay.
have right in the same level.
Oh, okay. Yeah. Okay. Thanks, brother. Yeah. read A, R2A, W1B, then R3B. Then R1A, then W2A, then R3. Okay. So let's draw the precedence graph. So anyone want to help me draw precedent graph? Hello.
Transaction 2 has an S to transaction 1
Okay. So yeah, transaction 2.
to 1.
Why?
Sir, the operations on A.
RA.
Yes, sir.
So it is completing means instruction. So only read, right?
Sir, the write operation from R2 to W2.
The item is not same.
So see, first you have to draw the precedent. First you have to see any complete instruction or not. First you have to see write A. So write A and WB, these are two different items, so not a complete instruction. Then you have to see write B. So these are not completing instruction. Then you have to see the read and read are not completing instruction. Then you have to see this instruction. So these are not completing instruction. So after that we have to see this. So WB write B. You have to see T1 to T3 write B and the read B. These are completing instruction. So you have to draw T1 to T3. Everyone got it? How to draw precedence graph? Hello.
Yes,
Hello. Am
sir.
I? Yeah. So then we have to check write B, then write B and write A. So these are two different data items. So yeah, it's okay. Okay, then you have to check read B. This read B and read A. So these are two different data items. So not conflict. So you have to check read B and the write A. These are two different data items. So it's okay. Then you have to check this. So read A and write A. So these are completing instruction. Then you have to draw T1 to T2. Everyone got it? How to draw precedence graph T1 to T2? How to? Hello? Hello, am I audible, right?
Yes, yes.
Yes, sir, you
Yeah.
are audible.
Okay. Okay, then you have to check WA. So see, WA and RA, these are completing instruction. You have to draw precedence graph. So yeah. So this from cyclic, this graph is cyclic or not?
No.
No, sir.
Okay. These are acyclic graph.
Yes, yes.
So means this is a complex serializable. Everyone got it? How to solve this problem? These types of problem, complex serializable.
Yes, sir.
You have to just means you have to draw precedent graphs, and you have to see these are cyclic or not. If cyclic, that means it's not complete serializable. If it is acyclic, means it is a complete serializable.
So, sir, read operations are not considered for this, right?
Yeah. So you have to see what are the completing instruction. Completing instruction means suppose read A, suppose R1A and R2A. These are not completing instruction, so you don't have to draw means as like this. If there are R1A
Window, am
means
I audible?
yeah.
I would like to ask from the Bhavya. Bhavya, can you explain what is serial means conflict instruction?
Yes,
Hello.
sir.
Yeah. Just
Sir,
explain
a
what you.
conflicting instruction would be if uh, two instructions from two transactions if a single data item is accessed by both of them.
Yeah, that is correct. And what are the condition? Conflict instruction, which with particular instruction or conflict instruction, which are not conflict instruction. Suppose you operate on the read write operation on the A data items. So can you tell me four condition what are? Hello?
Sir,
Yeah.
in case both try to write, there will be a conflict.
Can you again?
If both of them try to write to the same data item, they will have a conflict.
Yeah.
If one tries to write and the other tries to read, then also they will have a conflict.
Yeah.
And okay, the reads will not have a conflict. Okay, got it.
Yeah. Read on the same data items. If they performs the read operation, then it will not conflict instruction and will not compare with the another data items. Here you can see instead T2 operate on the A data items and T1 operate on the B data items. Then we not compare.
Yes, sir.
Yeah.
Okay, sir, got it.
Okay, so we'll move to next question. So this is same type of question. So you have to say, is this complete serializable or not? So please try to draw a precedence graph. So this type of question is very important. Please try to draw on. I will wait 2-3 minutes. Please write your answer on the chat box. So anyone got the answer?
So not serializable.
Yeah. Okay. Then others. Okay. So let me draw T1, then T2. There are 5 transactions, right? Okay. Okay. So first is R5 there, right? So read Z, then W1Y, then WY. So let's start in different color. So you will get. So WY, then R2Y, then W3Y, then read 4Y. Y. Okay, then W to P. Okay, let's start different color. So let's start black. So W to P. Okay, then read 5 R5P, P, then R1Q. So R1Q, RQ, and the W1Z, and the W1. So everyone got it? How to add this transaction? Hello, am I audible, right?
Yes, sir.
So then you have to draw a precedence graph, right? So T1, T2, T3, T4, T5, right? Okay, then you have to see conflicting instruction. So you have to see
First
RZ.
one will be T1.
Yeah. So you have to see first RZ. So RZ and WZ. See, these are conflicting instruction. So you have to T5 to T1. So there will be an as T5 to T1, right?
Yes.
Yes, sir.
Okay. Then
So 1
W.
to 2,
Yeah, 1 to 2,
T1 to 2, T2 to
2 to
T3,
3,
T2 to 3, right? Okay.
and T3 to
3 to
T4.
T4.
Okay. T3 to T4, right? Okay.
Sir, 1 from T2 to T5.
1 from T2 to
T5.
T5, yes. T2 to T5.
okay. So T2 to T5, right? Okay.
Yeah, WP.
Okay. So you will see the these are the cyclic T1, T2, and T5, right? If you see the graph T1, T2, and T5. So T1 to T2, T2 to T5, and T5 to T2. So these are from cycle, right?
Yes, sir.
So these are not completely serializable. Everyone got it? Hello.
So at least one cyclic order is there, then it is not the
Yeah. Is one cycle is there. It is not complete serial as well. So if you have any doubt, you can ask because these are the very important questions. Otherwise, I will move to the next question. Okay, no issue. Okay. So figure 3 shows the precedence graph of a complete serializable schedule S. Then you have to tell how many serial schedule are there to S can be complete serializable. Yes, so you have to tell how many basically complete serializable. So yeah. So I will wait 2-3 minutes. You can answer in the chat box. So one student's got right answer 3. So plus, can you tell how is the 3 right answer? What are the possible combination?
Sir, we can solve this using topological sort.
Yeah. So the possible serial schedule. So can you tell what are the possible serial schedule?
T1,
T1, then
T2,
T2,
then T3,
then T3,
then T4,
then T4,
then T5.
then T5. Okay. Then others,
T1,
T1,
T2,
T2,
T4,
T4,
T3,
T3,
T5.
T5, and
T1,
T1,
T4,
T4,
T2,
T2,
T3,
T3.
T5.
Yeah, very good. So if you have any doubt in this question, you can ask. Okay. Okay, we'll move to the next question. So schedule S is given as R1A, W1A, R2B, W2B, and W2A, and RA, WA. So the given schedule is 2P lockable or not. So you have to tell is this schedule is two-phase lockable or not. So you can answer in the chat box. Please.
Yeah.
Yeah.
You can continue,
Yeah. So can anyone tell us what is the two-phase lockable condition? So condition is locking can be done in two phase. Number one is growing phase. And the shrinking phase. And there are some rules. After shrinking phase, growing phase is not possible. After shrinking phase, growing phase is not possible. Growing phase is compulsory. But shrinking phase is optional. So everyone got this one? Hello?
Yes, sir.
Okay. So let's write the transaction. So let's define colors. T1, then T2. So first is R read A and the write A. So I have to apply a lock. So lock exclusive lock, right? So because we have write the data A. Everyone got it?
Sir, could you repeat this once again?
So see, there are two types of lock.
Sir,
Shared lock
an exclusive.
and the exclusive lock. Suppose if you want to read the data, only read the data, then you can apply shared lock. Right?
Yes, sir.
Suppose if you want to read write the data or both,
We need
read or write.
exclusive lock.
So we have write also and read. So you have to apply exclusive lock, right?
Yes, sir.
Okay. Then read B, R2B, and the so you have to apply exclusive lock, right?
Yes, sir.
Okay, sir. Then also you write this is R1, sorry. This is R1. Sorry, there is some mistake. So you lock on means you read the data and write the data. First you have to unlock, right? Then we can apply exclusive lock. Right? Is this one clear?
Yes, sir.
Okay. Okay, so see.
Sir, you missed W2A.
Okay. Okay, sorry. W. Okay, yeah, sorry. Thanks. Okay, so unlock. So then you have to lock again. So lock exclusive A, then write A, then you have to unlock. Then you have to again apply exclusive lock. Then read A, then write A. Everyone got it?
One things.
Yeah.
I need to do voice locking because
Your voice is bits.
we are writing the same I mean, we are operating on the same A, right? A. So only one I lock.
Yeah, you can. Yeah. So suppose there is a transaction one, then you can unlock. You can. Suppose it already lock applied on T2 transaction, you have to unlock. Then we can apply.
No, T2 transaction is okay because the two different objects.
Yeah. You can do it.
In T2, we have to lock B first, right?
So yeah, sorry. Lock B. Sorry. So everyone got this? Okay. Then you have to see. This is the growing phase.
Do we need to unlock over here in the transition queue before?
Yeah, you can. This shrinking phase is optional, right? So you can unlock or you can also unlock.
Okay, next time we don't have to write.
Okay. So this is the growing phase, right?
Yes.
And this is the shrinking phase.
Yes.
Then this again is growing phase, right?
Yeah.
Again is sinking phase. So 2PL, two phase lockability does not allow. So basically 2PL after sinking phase is not after sinking phase, growing phase is not possible. So there is a sinking phase, then again growing phase. So this schedule cannot be two phase lockable. Everyone got it?
Yes, sir.
Okay, so any doubts in the week 10 activity practice? Okay, then sir, we can bind up this.
Hello? Yes. Okay, so
Thank you.
yeah.
Sir, can you
Yes.
share the slides of today and Thursday's session on discourse?
Yes, sir.
Okay.
Okay, sir. Thank you.
We'll do that. Yeah.
Thank you, sir.
Okay. Thank you, everyone. Yeah.
Thank you, sir.
Thank you.
Thank
Thank you.
sir.
Thank you, everyone.
Thank you, sir.
Sir? Hello?
Yeah. Hello.
Sir, I have a doubt in week 6 question. Sir, can you please explain?
Okay.
Sir, in week 6 graded assignment question 9.
Hello. Yes.
Sir, in week 6 graded assignment question 9.
Okay, week 6 graded assignment question 9. Okay, so can you post it on Discourse? Okay.
Sir, I posted it on Discourse yesterday, but I didn't get a reply.
Okay, let me check. Week 6, right?
Yes, sir.
Yes, question number?
Question 9.
Question 9. Okay, the department building, those. Yeah, okay. So we already discussed this in detail, yeah, Vishaka, in the week 6 live session.
Sir, when you have discussed it?
In week 6 live session.
Week 6?
Sir, week 7.
Week 7. It is week 7 question?
Week 7 live session.
No, week 6 live session only. Okay, this is graded question. Okay.
Okay, sir, I will check it once.
Similar kinds of questions discuss.
So basically, I have a doubt how to break it in 2NF in that part. How to decompose it in 2NF.
Okay, see, first you need to check functional dependency, which is violating the 2NF condition, right? So then take the closure of that left-hand side of a particular functional dependency and make it as a one table.
Can you mute yourself? Somebody give me.
Sorry. Okay, Vishaka, we'll post the solution on the Discourse, okay? Or otherwise, you can ask in the next live session also.
Okay, sir, I will go through the solution, and if I didn't understand it, I would ask in another session.
Can you send me the link of that Discourse post? I'm not able to find it. What is the title for that? Week 6.
Can you tag user Vishaka?
Yes. Which question in Discourse? Vishaka, can you tag me on that question? Hello. Yes, Vishaka.
I see searching for that.
Hello, Vishaka. Are you there?
Yes, sir, I'm there.
Okay, so can you tag me in the discourse post?
Sir, I'm unable to do it.
I'm not able to see the question, your post also. Okay, you can create a new post, okay, and tag me in that. Is that okay? Okay, Vishaka, you can create a new post and tag me, okay?
Yes, sir. I will search and I'll let you know.
Okay.
Okay. Thank you. Thank you.